Hello dear students, welcome to ECE Academy Benefactor. Today the topic of the class is implementation of combinational logic using MUX. MUX is the short form of multiplexer. The topic is from the combinational circuit. The subject name is digital electronics. In this class we will be seeing implementation problems and their solutions. 3 questions we have covered here. So, let us start with the first one. The first question is, implement the following Boolean function using 8:1 MUX. The given Boolean function is f a comma b comma c is equal to summation m 1 3 5 6. Solution: write the given Boolean function once. F a b c is equal to summation 1 3 5 6. We have to implement using 8:1 MUX. So, you know what is 8:1 MUX? 8:1 MUX means it is having 8 inputs. So, which is written as 0, 1, 2, 3, 4, 5, 6, 7. So, 0 to 7 means total 8 inputs are there. 8 means 2 to the power 3. So, 3 select lines are taken. 1, 2, 3. 3 select lines are taken as S0, S1, S2. So, 8 inputs, 3 select lines and 1 enable input to enable the multiplexer. 1 indicates 1 output, which is symbolically represented by Y. The output is F here. The function F is coming at the output. Now, at the input, how to connect? So, here the list of minterms is given as 1, 3, 5, 6. Connect 1, 3, 5, 6 to 1. To input 1. You see here I have shown it by green line. 1, 3, 5 and 6. So, 1, 3, 5, 6 are connected to this green line, which means is connected to one input. So, the given list of minterms are connected to 1. And the leftover numbers 0 to 7 now. So, 1 to 1, 3, 5, 6 you have connected to 1. The leftover numbers like 0, 2, 4, 7. These are connected to 0, that is connected to the red line. Okay. So, 8:1 MUX is implemented. Input select lines are S0, S1, S2. Let us now see the next problem. Next question is, implement the following function using 4:1 multiplexer. F a comma b comma c is equal to summation m 1 3 5 6. It is saying to implement using 4:1 MUX. 4 means the maximum numbers are 0, 1, 2, 3. For 4:1 MUX means 4 inputs. How many inputs we can take? Only 0 to 3. But the list is having more minterms. In this case, when the minterm list is more than the given MUX, we have to go for implementation table. What we are supposed to implement using 4:1 MUX. So, we are having 4 inputs D0, D1, D2, D3. In this the first variable, take it as input line. We have written it here as A bar A. Okay, so this is the outer structure D0, D1, D2, D3, A bar A. 4:1 MUX means how many select lines will be there? 4 means 2 to the power 2. So, 2 select lines will be used. So, those 2 select lines will be B and C. So, in this implementation table, first we have written D0, D1, D2, D3 and then written the numbers 0, 1, 2, 3, 4, 5, 6, 7. After writing this implementation table, we have to circle the minterms which are given in the list. So, its the given list is 1, 3, 5, 6. We have to circle them. Okay. Now, how to write this last row? So, here none of coming to this column, none of the numbers are circled, so we will put 0. Here both are circled, so we will put it as 1. Here the bottom one is circled, bottom one means A, so we will write it here as A. In this one, 3, the above number is circled, 3 means A bar. So what does it mean? D0 is connected to 0, D1 is connected to 1, D2 is connected to A, and D3 is connected to A bar. So let us draw it here. 4:1 mux. The inputs are D0, D1, D2, D3. Two select lines S0, S1. S0 is connected to B, S1 is connected to C, and one output line 1 Y. The output variable is F, function F. So D0 is connected to 0, D1 is connected to 1, D2 is connected to A, and D3 is connected to A bar. So we could complete the implementation of 4:1 mux for this list of minterms. So implementation table is used when the list of minterms is more than the given mux inputs. Okay, now let us see the third question. The question is, implement the following Boolean function using 8:1 mux. The function, Boolean function is f p q r s summation m 0, 1, 3, 4, 8, 9, 15. We are supposed to use 8:1 mux. 8:1 mux. It means 8 inputs are to be there. 8 inputs means it will start from 0 to 7. 8 inputs are to be there. So 8 inputs will start from D0, D1, D2, D3, D4, D5, D6, D7. But here the list of minterms are greater than 7. Okay. So definitely here we have to go by implementation table method. So what is the implementation table method? So 8:1 mux, we have to use it using 8:1 mux. So we have written the inputs D0, D1, D2, D3, D4, D5, D6, D7, and in this 4 variables, the first variable is taken as input line for this implementation table. It's written as P bar P. Okay, and then written all the numbers from 0 to 15, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is outer structure of the implementation table. Now we have to circle the numbers which are there in this list of minterms. So 0, 1, 3, 4, 8, 9, 15. These numbers are there in this list of minterms, so we have circled them. Now we have to see what is this column value. So here both numbers are circled, so it will come as 1. Both are circled, value is 1. None are circled, so its value is 0. The above one is circled, which is equal to P bar. Above one is circled, so its value is equal to P bar. None are circled, so connected to 0. None are circled, so it's connected to 0. The bottom one is connected to circled, so will be P. So what does it mean? The input D0 is connected to 1, D1 is connected to 1, D2 is connected to 0, D3 is connected to P bar, D4 connected to P bar, D5, D6 connected to 0, and D7 is connected to P. Okay, so we have to implement using 8:1 mux. 8:1 mux means 8 inputs D0, D1, D2, D3, D4, D5, D6, D7. How many select lines? 8 means 2 to the power 3 is 8. So 3 select lines S0, S1, S2. So the leftover variables QRS are connected to the select lines QRS, and one enable input to enable the multiplexer. So where is D0 and D1 connected? D0, D1 are connected to 1. So they are connected to 1 input. And next D2, D5, D6 D2, D5, D6 are connected to 0, that is connected to blue line to 0, and D3, D4 are connected to P bar. So, we have taken one line here P, pink line, another part is connected through a NOR gate. So, the output of this NOR gate will be P bar and this line is P. So, D3 and D4 are connected to P bar and D7 is connected to P. This is how we can implement the multiplexers. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.